So this is my summary for the chapter 8. It is all about subnetting IP networks. So designing and implementing and managing an effective IP addressing plans ensure that the networks can operate effectively and efficiently. This is especially true as the number of the host connection to a network increases. Understanding the hierarchical structure of the IP addresses and how to modify that hierarchical in order to more efficient meet routing requirements is an important part of planning an IP address scheme. In the original IPv4 addresses, there are two levels of hierarchy, a network and a host. These two levels of addressing allows for basic network groupings that facilitate in routing packets to a destination network. A router forward packets based on the network portion of an IP addresses. When the network is located, the host portion of the address allows the identification of the destination devices. However, as the network grows, with many organizations adding hundreds and even thousands of hosts to their network, the two-level hierarchy is insufficient. Subdividing a network adds a level of the network hierarchy, creating an instance three-level network and sub-network and host. Introducing an additional level of to the hierarchy creates additional subgroups within an IP network that facilitates packets or faster packets delivery and added filtration by helping to minimize local traffic. The broadcast domain. In an Ethernet LAN, devices use broadcast to locate other devices and services. The devices use Address Resolution Protocol or ARP, which send layer 2 broadcasts to unknown IPv4 addresses on the local network to discover the associated MAC address services. A host typically requires its IPv4 addresses configuring using the Dynamic Host Configuration Protocol (DHCP), which sends broadcasts on the local network to locate a DHCP server. Problem with the largest broadcast domain. A large broadcast domain is a network that connects many hosts. A problem with a large broadcast domain is that these hosts can generate excessive broadcasts and negatively affect the network. Slow network operation due to the significant amount of traffic it can cause. Slow devices operation because a device must accept and process each broadcast packet. And the solution to reduce the size of the network to create a smaller broadcast domain is a process called subnetting. These smaller networks spaces are called subnets. So, reason for subnetting. Why we need to subnet? Subnetting reduces overall network traffic and improve network performance. It also enables an administrator to implement security policies such as which subnet are allowed or not allowed to communicate together. There are various ways to use subnet to help manage network devices. Network administrator can group devices and services in subnet that are determined by the location such as the floor in the building, organization unit, the device type, and any division that makes sense for the network. Um, the octet boundaries. Every interface on the router is connected to a network. The IPv4 addresses and subnet masks configured on the router interface are used to identify the specific broadcast domain. IPv4 subnet are created by using one or more of the host bits as network bits. This is done by extending the subnet mask to borrow some of the bits from the host portion of the address to create additional network bits. The more host bits that are borrowed, the more subnets that can be defined. Networks are most easily subnetted at the octet boundary of /8, /16, or /24. Subnetting on the octet boundary. Um, this is all about to understand how subnetting on the octet boundary can be useful. Assume an enterprise has chosen the private address, which is the 10.0.0.0/8 as its internal network address. Network address can connect 16 million, that 777,214 hosts in one broadcast domain. So the enterprise should further subnet the 10.0.0.0/8 addresses a docketed boundary of /16. The class subnetting. The example seen so far borrowed host bit from the common /A/16/24 network prefixes. However, subnets can borrow bits from any host bits portion to create one other mask. For instance, A/24 network address is commonly subnetted using a longer prefix length by borrowing bits from the 4 octet. The class, the classes, creating two subnets. So IPv4 network addresses, then the first IPv4 host addresses, then the last IPv4 host address, and IPv4 broadcast address. Subnetting formula. To calculate the number of subnet that can be created from the bits borrowed, use the formula that is display the possible numbers of the subnet that can be created when borrowing 1, 2, 3, 4, 5, or 6 bits. So subnetting based on the host requirements. There are two considered when planning subnets. The number of host addresses required to each for each network and the number of individual subnet needs. So the number of the host addresses required in a large subnet will determine how many bits must be left in the host portion. Recall that the two of the address cannot be used, so the usable number of address can be calculated as 2 raised to n minus 2. So traditional subnetting waste addresses. Using traditional subnetting, the same number of addresses is allocated for each subnet. If all subnets have the same requirements for the number of hosts, this fixed size blocks would be efficient. However, most often that is not the case. Although this traditional subnetting meets the needs of the largest LAN and divided the address space into an adequate number of subnets, it results in significant waste usable address. Further, this limits future growth by reducing the total number of the subnet available. This inefficient use of addresses is characteristic of traditional subnetting. Applying the traditional subnetting scheme to this run is not very. Subnetting is subnet. And network addressing plan. Planning network subnet requires examination of both the needs of an organization, network usage, and how the subnet will be structured. Performing a network required study is the starting point. This means looking at the entire network and determining the main section of the network and how they will be segmented. The addresses plan include determining the needs of each subnet in terms of size, how many hosts per subnet, how host addresses will be assigned with hosts, which requires static IPv4 addresses, and which hosts can be use their CPU for obtaining their address information. The size of the subnets involves planning the number of the hosts that will be required in IPv4 host addresses in each subnet of the subdivided private network. So, so this is my summary for the chapter 8, and thank you.